So, good morning. Welcome to the sixth lecture of Geography from Possible IAS. So, in the previous lecture, we had discussed continental drift hypothesis and its various evidences, and the theory of plate tectonics, the various evidences of plate tectonics like hotspots, paleomagnetism, and divergent. And we had started with the different plate boundary interactions. So the first thing that we did was the divergent plate boundary. In a divergent plate boundary, we studied divergence in an oceanic boundary as well as in a continental boundary, and as in an oceanic plate as well as in a continental plate. Okay, so when it is in an oceanic plate, we have the formation of mid-oceanic ridges, whereas in the continental plate, we have the formation of rift valleys, which lead to the formation of linear seas, and ultimately it leads to the formation of ridge valleys with further expansion. Okay, so the next type of plate boundary interaction that we are going to study is known as a convergent plate boundary interaction. So as the name suggests, convergent, that means two plates are going to come closer together. Okay, so as in the divergent plate boundaries, we did that divergent plate boundaries, they are constructive boundaries as a new crust is being created in the divergent plate boundary. So now we will study the convergent plate boundary. So what is a convergent plate boundary? Where two plates, they collide with each other, okay, or they come towards each other. Okay, so when one plate comes towards the other one, what happens? There are three types of interactions. Either a continental plate can come towards either to a continental plate and an oceanic plate, they can come towards each other. Two oceanic plates can come towards each other, or two continental plates can come towards each other. Okay, so we'll take all of these scenarios one by one. Okay, so now the first scenario that we are going to consider is the easiest one, that is the one oceanic crustal plate is moving towards the continental plate. Okay, so here what happens, that since we all know that the oceanic crust is very dense, so oceanic crust is very dense, right? And the continental crust is light. So we have already established this in the previous lectures. So the continental crust is dense and the oceanic crust, it is light. So what happens here is that, so when you take suppose a ball bearing and you put it in water, what happens? Since it's dense, it sinks into the water. Or if you take a rock and you put it in a pond, what happens? The rock is denser than pond. So denser than the water in the pond, and it sinks inside the pond. So what happens? The oceanic lithosphere with time, with age, as it becomes cooler, it gets denser, and it becomes so dense that it becomes denser even than the asthenosphere. Okay, so what it does is that it will try to sink into the asthenosphere at any chance it gets. Okay, so the oceanic crust, it tries to sink within the asthenosphere. So now the oceanic crust is moving in this direction, the continental crust is moving in this direction, right? So what happens, that this oceanic crust, since it is dense, so the oceanic crust is the continental crust is able to bully it, okay, and it overrides it. Whereas this is already dense, it's heavy, so it tries to subduct beneath the into the asthenosphere, okay, like a rock, like how a rock sinks into water. Okay, so now what is happening, that the oceanic crust is it is sinking beneath. So now this angle, what angle it is forming, right here, this angle. So this angle that is being formed, what will this angle depend on? So this angle can be 90 degrees, it can be acute, obtuse. Okay, what does it depend on? It depends on the density of the oceanic crust. Okay, so what happens is, if the oceanic when the oceanic crust is young, so obviously young, it is warm. So warm things, they are more buoyant. So when the young oceanic crust is warm and buoyant, so the angle of descent is small. It can vary from 20 to 45 degrees. But when it becomes older, it gets denser. Okay, so when it's old, it is dense. And then the angle can become really high. It can go up to say 90 degrees. Okay, so this is how the angle of subduction, it depends on the density of the oceanic or the subducting plate. Okay, so now this plate, oceanic plate, is moving beneath the continental crust into the asthenosphere. So this process where the oceanic crust, one plate, one lithospheric plate is moving beneath the other lithospheric plate into driving straight into the asthenosphere, that process is known as subduction, right? So this process is called subduction. When one oceanic plate moves beneath the other oceanic plate and drives straight into the asthenosphere, that process is known as subduction. And this zone where this is happening, it is known as a subduction zone. Okay, so now what have we seen? That the oceanic plate, since it is denser, it is going to move beneath into the continental crust. Okay, so now what happens is that at this point where subduction is taking place, a feature is made which is known as a trench. Now these trenches are actually the deepest portions in the earth, and there are various trenches, so we will be discussing that. There are many trenches. So the most common is a Mariana Trench, which is located in the Pacific Ocean. Okay, then you have the Aleutian Trench. So again, it is related to North America. Then it's not given in this diagram, but here at South America boundary, you have a Peru-Chile Trench. Peru-Chile Trench. Okay, so these are the different trenches, the Tonga Trench, Mariana, Aleutian and Peru-Chile. So these are the important trenches in the Pacific Ocean. Okay, so here what is happening in the Peru-Chile Trench? The Pacific plate is subducting beneath the South American plate. Okay, so that is how this trench is formed. So first thing that is formed here is a trench. So now you see this is another feature which is formed, which is known as a continental volcanic arc. So how is this continental volcanic arc formed? First of all, it is formed on the plate which is on the continental crust, right? So what happens is it is formed on which plate? That means it is formed on the plate which is overriding the subducting plate. This is not formed on the subducting plate. It is formed on the plate which is overriding the subducting plate. Okay, so it is found on the continental plate in this case. So now what happens is that when the oceanic lithosphere is subducting, so what happens in this case is that the rocks of the subducting oceanic lithosphere, they have a lot of, so the rocks of oceanic lithosphere, they have a lot of water in it. Okay, the lot of water is present. So there are, like we did in the previous one of the previous lectures, that there are minerals such as amphiboles. Okay, so these minerals, they have water content. These are hydrous minerals. So like the formula of amphibole is an oxide of magnesium, silicon, iron dot 2H2 dot 3H2 dot 4H2. That means it has some amount of water molecules with it. So now when it is going under so much of immense pressure, what happens is that this water is squeezed out. Okay, so all this water that is present within the oceanic lithosphere, it is squeezed out. Okay, so the water is squeezed out. Now obviously this water is coming at so much of high pressure and temperature in the asthenosphere. So at a depth of around 100 to 200 kilometers, this process is happening. So the temperature is so high, so then melting takes place. Okay, so this water is really hot, so it will melt this part of the asthenosphere and take it along with it. Okay, so now what will be the composition of this melt? Now when we did divergent plate boundaries, I told you that during the divergent plate boundaries in the mid-oceanic ridge, the basaltic lava comes out. Right? We did the basaltic lava comes out. Now here what happens at this point of time in the asthenosphere, the lava which is formed is again basaltic. correct? But then this magma, this all this molten material, see, the molten material becomes warm and buoyant, so it moves up, right? So this molten material will move through the continental crust, so obviously it will melt some portion of the continental crustal rocks also. Okay, so then this magma that finally reaches the top, that is known as, the composition changes from basaltic and it becomes more andesitic. So the basic difference between basaltic magma and the andesitic magma would be that basaltic magma, it has a lesser amount of silica as compared to andesitic magma. So now what happens is magmas which have a high amount of silica, that is SiO2, these magmas are very thick. Okay, since the silica bonds are very strong, so these magmas are very thick, whereas basaltic magmas, they are fluid. So like if you try to relate it to some daily life examples, so basaltic magma would be like water, very fluid. If you throw water, it will spread over. Whereas if you say a more silica rich magma like an andesitic or granitic or a granodioritic magma, that sort of magma, it is very thick, like your tomato ketchup. So if you throw tomato ketchup on the table, it does not have a tendency to flow that much, that fast as water does, right? So these are andesitic magmas which come to the surface of the earth at the continental volcanic arc. So now what will happen? These magmas are thick, so they will build up in the chamber. So then the pressure will, so these volcanoes, what will happen? So these magmas are coming, these are very thick, so they don't tend to move up very quickly. So obviously in this region, these volcanoes, these magmas will start depositing, but the new magma is also shooting up from below. So what will happen at one point of time, because of their high viscosity, what happens that there is a lot of pressure that is built up in the volcano, and finally an eruption takes place. So the eruptions in the continental volcanic arcs, they are very violent eruptions. Okay, so these are very violent eruptions. They have a lot of volcanic ash. So we have done all this when we studied volcanism. So these have a lot of volcanic ash. Then these have a lot of volcanic blocks and cinders. So one of such examples was the eruption of Mount St. Helens. So this is a volcanic mountain. So Mount St. Helens, which is in America, it erupted in 1980. So this eruption is an example of a continental volcanic arc eruption. Okay, so now again let's discuss once more, revise it. What is it? So in the continental plate, in the convergent plate boundary, there will be, the first thing that we have studied is a convergence between an oceanic crust, and a continental crust. Now oceanic crust, it is denser, so it subducts beneath the continental crust, right? And it goes into the asthenosphere. In the asthenosphere, water is released from the oceanic crust, and there is high temperature, so melting occurs. Now this molten material is buoyant, it moves up. Initially its composition is basaltic, and as it moves up, it mixes with the continental lithosphere, and then its composition changes to andesitic. Now these andesitic magmas are very viscous, so the type of eruptions that take place because of the andesitic magmas are very violent. So in these eruptions you have a lot of volcanic ash, blocks and cinders, right? So this completes the first type of boundary interaction under convergent plate boundary. So we have done continental and oceanic convergence. So now one thing can happen is that two oceanic crusts can come towards each other. So that in that case, what happens is that one of the older ones, so one has to be younger and one has to be older. So the younger one is less dense and the older one is more dense. So again what happens, the denser one will subduct. So again the same process will happen. The older oceanic plate, it subducts beneath the younger oceanic plate, and again a trench is formed. Again the angle of trench will depend on the density of the oceanic crust which is subducting. So now again what will happen in this case, so in this case the volcanism that was formed was known as a continental volcanic arc, whereas in this case it is known as a volcanic island arc or simply island arc. Okay, so here if you see, this is a trench that is formed, again at the zone of subduction, trench is formed. So now you have to imagine this in a little 3D, that it's not just, the thing is not happening at a corner like this, it is happening along the whole of length like this. Okay, so this whole length the trench will be formed, right? So again, in the zone part, melting will occur, the rising will happen, and volcanism will happen. So here what happens is, since the oceanic, this is, so in because of this volcanism, volcanic island arcs are formed. But here, there what was happening? The magma, the basaltic magma which was rising, it was mixing up with the continental crust, hence its composition was changing. Here, the magma which rises, it mixes with the oceanic lithosphere only. So its composition does not change much and it remains a mafic magma only. So here the volcanic island arc is formed, okay, or which is simply known as island arc. So here we did two features in continental and ocean, a trench and a continental volcanic arc. Whereas in this, what did we study? We studied two features, which is a trench and a volcanic island arc, or simply known as an island arc. So, revising it again, what happens that when two oceanic plates they converge, what happens? One which is older, it subducts beneath the younger one here, and the older one subducts beneath it, and the oceanic crust and a trench is formed, and because of the melting and rising of the magma, pressure melting, what happens? A volcanic island arc is formed. So this completes two types. Now the third condition is when two continental lithospheres they move towards each other. Okay, so what happens in this case is that when two continental plates they move towards each other, they are almost of the same density. So the subduction zone is not very wide. Okay, and subduction is not very common here. So what happens is that these two plates these are moving towards each other, right? So these volcanoes are formed. Sorry, mountains are formed. So what happens in two plates? None of them is going to subduct. One is not going to subduct beneath other. So they will come closer and the materials between them will start rising and that will form mountains. Okay. So such mountains are formed. Obviously, when such mountains are formed, what happens? When these were two separate continental plates, one was here and one was here. So what was separating them? Some ocean or sea? Like when it was the Indian plate, suppose this is the Indian plate and this is the Eurasian plate, right? So what was separating them? The Tethys Sea. So now this part is oceanic crust. So now these are coming towards each other, right? So obviously oceanic crust is subducting beneath these two. The oceanic crust is being overridden by these continental plates as they come towards each other. So obviously there will be small subduction which will be happening, right? So subduction happens on one side, and obviously if subduction is happening there has to be volcanism. So subduction is on which side the subduction is happening? So when, suppose now let's take this, consider this small diagram. This is one continental crust, this one is moving towards it. Okay, so यहाँ बीच में you had the oceanic crust. So this is moving here. So obviously the oceanic crust is also moving. So the oceanic crust will start subducting in this direction. So obviously the volcanic island arc will be formed here. Continental island arc will be formed here, or if it subducts in this direction, the continental island arc will be formed here, right? So in a continental convergence case, the position of the continental volcanic arc, okay, the position of the continental volcanic arc will depend on which side the subduction is there. So sometimes the subduction zone is very, very away from the continental crust. So in that case, you will not have a continental volcanic arc, you have a volcanic island arc. Okay, so in the case of continental convergence, it is a little complicated as there is a subduction of the oceanic crust which was present beneath the previous continental crusts. As they come together, obviously the continental crust, it will vanish away and and it will result in subduction. So and And the position of the continental volcanic arc will depend on the where the position of zone of subduction is. As if it is under the continental crust, you will have continental volcanic arcs, and if it is away from the continental crust, you have volcanic island arcs. Okay, so here what is the main feature that is found here? The main features that is found here is the mountains. So when these continental crusts, they have already subducted the oceanic plate. So when they have subducted the oceanic plate, they come together, they collide. All this material deposits that were also present in the ocean, everything, it rises up together and it forms mountains. So what are the examples of these mountains? Alps, of course the Indian example, Himalayas, and Urals. Where are the Urals? The Urals are in Russia, Alps are in Europe, and Himalayas, of course, everybody knows, in India and China. Okay, so such mountains are formed because of it. Okay, so what happens is that these rocks, these are highly fractured rocks. Obviously so much of pressure is being exerted from both the sides, so these rocks are very fractured. Okay, and these are very highly metamorphosed. Obviously so much of pressure is acting, temperature is increasing, volcanism is happening. So here in this region you will find rocks which are metamorphosed. We have already done what metamorphic rocks are. Metamorphosed. Then you have sedimentary rocks. Why do you have the sedimentary rocks? Because all these sediments that were present in the ocean, they are also uplifted. Then you have igneous rocks, obviously, because there is supposed to be some partial melting in the subduction zone. So because of that, igneous rocks will also be there. So when you go to Himalayas, you study the geology of Himalayas, you find that there are huge bunches of metamorphic and sedimentary rocks, and from them dikes of volcanic rocks. Like I told you in one of the previous lectures, that dikes are vertical columns of volcanic igneous rocks. Okay, so these dikes of volcanic rocks are rising. Okay. So the important features about the continental lithosphere, when we revise, that when two continental lithospheres move towards each other, the oceanic crust between them, that subducts, and when they collide, they form mountains. So examples of such mountains are Alps, Himalayas, and Urals. Okay. So these are the examples of such mountains, and these mountains are formed. So in the convergent plate boundaries, there are three types of convergence, either between a continental and oceanic crust, a oceanic crust, or a continental crust and a continental crust. So that completes the part of continental convergence plate boundaries. Okay, so now we have done divergent boundaries, we have done convergent boundaries. So now what did you see in the convergent boundaries? That the crust is being eaten away. One part of crust is being eaten away, here and here. It is being eaten away by the asthenosphere. It is going down and it is melting. So this is known as a destructive plate boundary. Okay, so here the crust is the older crust. It is going down, it is subducting and it's melting, hence the crust is depleting. So this is known as a destructive plate boundary. So when it comes to the UPSC exam, what kind of questions can be asked is that, first of all, you can be asked which of the following is a constructive plate, which of the following is a destructive margin. Okay, or then you can be given examples, like suppose you're given the name of certain mountains like Himalayas, Urals, Alps. Okay, or then you're given the example of Hawaii, or you're given the example of some other San Andreas fault. So they will ask you that you match it with what type of plate boundary interaction is found there. Okay, so now what is the next thing that we have to cover? That is the transform fault boundary. So what is a transform fault boundary? So in a transform fault boundary, two plates, they are just sliding past each other. One is moving in this direction, one is moving in this direction. So they're just sliding past each other, right? So such plate boundaries, when they are not coming towards each other or going away from each other, they are known as transform fault boundaries or transform plate boundaries. And these occur in a huge break in the Earth's crust. So what happens is that the lithosphere, since we have already established that it is very brittle. So what happens? Something is brittle, obviously it will break very easily. So there are huge breaks in the continental crust, and these breaks, they are known as fractures. Okay, so because of these fractures, what happens is here, so these, along these fractures there are movements. So these breaks in the earth's crust, they are known as fracture zones. Now obviously these are fractured zones, so here again the convection current is going on, right? So suppose this is one plate boundary here, and there is one plate boundary here. So with the convection current, it is going in this direction, and with the convection current, it is going in this direction, right? So these are moving past each other. So when among the fracture zones, there is a presence of movement in the Earth's crust, where the two plates are moving away from each other, and such plate boundary interactions are known as transform fault boundaries. So the most typical example of this is the San Andreas fault, which is present near Mexico and Los Angeles. It is present in America, so in the North American plate. So the North American plate is, the Pacific plate is moving this way, the North American plate is moving this way. So because of that, a transform boundary is formed in the San Andreas fault, and it is very, very important because a lot of earthquakes are seen in this region. Okay, now as far as seismicity is confirmed, that is the presence of earthquakes is concerned, all the three types of boundaries can have a good amount of earthquakes. Okay, so in the transform fault boundaries, two boundaries, they are sliding past each other because of the fracture zones which are developed in the surface of the earth, and the typical example of this is the San Andreas fault. And there is another fault which is known as the Alpine fault. Where is the Alpine fault present? It is present in New Zealand. Okay, so two examples are important. The San Andreas fault, this is very, very important. So now just to give you an example of a type of question, so question can be here which can say match the following. So number one option will be Mariana Trench, number two option is Alps, number three option is San Andreas fault. San Andreas fault. Okay, so then you have to match it, and you have three options: convergent boundary, ocean continent, convergent boundary, continent continent, and transform fault. So now you know that Mariana Trench is formed when an oceanic plate, it is subducted beneath the continental crust. So you have this. Then Alps, you know when it is formed, when two continental plates converge. And when San Andreas is formed, it forms when, because of a transform fault. So such questions can be seen in the UPSC prelims examination. So be careful and study the examples. So there are a lot of examples, but please study the typical ones, the ones which are very, very common. So like Aleutian Trench, Mariana Trench, Peru-Chile Trench. So these are the trenches that you should know about. Tonga Trench. So these are the ones that you have to study. Now there are hundreds of such interactions there, so you don't have to study all of them. There are minor places, John de Fuca, there's Nazca, there's Coco, so there are so many of them. So you have to study limited, whatever is more important, or whatever are the classic examples, I would rather say. Okay. So now we have studied plate tectonics, we have studied the three types of boundaries. So now we will come to what is known as geomorphology. Okay. Okay, before that, see here in geomorphology, number one. So in geomorphology, what we have to study is, first of all, what geomorphology is. So now we are done with plate tectonics and continental drift hypothesis. So now what did we study? That because of this, a lot of features are formed on the earth: mountains, trenches, valleys, folds. So all of these things are formed on the earth. So okay. So now what is geomorphology? Geo means earth. Morphology means physical appearance. So this is known as geomorphology. So what actually forms the geomorphology of an area? What are the things, what are the forces behind geomorphology? How is earth, how does so much of variation happen on the earth? Okay, so in geomorphology, there are two types of forces which affect us: exogenetic and endogenetic. So we'll study these forces in detail slowly. So just giving you the basic outline right now. So there are two types of forces: exogenetic ones which happen on the outer surface of the earth, and endogenetic which are present on the inside of the earth, right? So these forces, they constantly try to keep countering each other, and because of that, various landforms are found on the surface of the earth. Okay, so what is a landform? Landform is basically the features which are found on the earth. So what can be a landform? A landform can be a mountain, it can be a lake, okay? It refers to the earth's surface configuration. So what is landform? It refers to earth's surface configuration. Okay, so this is known as a landform. And what is landscape? So landform is different from landscape. It refers to the total total average of different landforms that are present in the area. So whatever all the landforms of an area, when they give the total, when you see it in totality, so that area that is formed because of the different landforms, that is known as the landscape. So the total assemblage of landforms is known as landscape, right? So now another term that you hear quite often in geography is known as relief. Relief. So what is relief of an area? So so at times they say this is a low relief area, this is a high relief area. So what does that mean? It means that how much is the difference between the different heights in an area. So like if you go to Himalayas, this area is high, say a kilometer. This area becomes low. Then this area is 500 meters. So there is a variable relief. So what is relief? Relief refers to the geographic difference in the elevation of different areas in a landscape. Okay, so it refers to the difference in elevation at different points in an area. So relief is difference in elevation at different points in an area. Okay, so like if you consider the relief of the earth, at one point what do you have? Mount Everest. At one point what do you have? Mariana Trench. So this is a very high relief. Earth has very high variety of relief. So when you see the plains, suppose the Indo-Gangetic plains or the Great Plains of America. So what happens in these areas? There is not much relief. Everything is pretty much at the same level. So the plain areas, they have a very monotonous relief. Okay. So now After relief, the next term that you study is structure of rocks. This also you come across very common. So what is structure of rocks? Structure of rock refers to the composition, arrangement, and characteristics of rocks. Okay, so what is the composition of the rock? What is the composition? Is it just silica? Is it made up of feldspars? Is it made up of feldspars and silica both? Or does it lack silica rich minerals altogether? Okay, so the composition, structure of rock accounts for composition. Then arrangement. What is the crystal structure? How are they arranged? That also forms a part of structure. And finally, what are the characteristics of the rock? Like we will study two concepts of folding and faulting. Or like I told you in the previous lecture, what is dip and strike of the rock? What is the trend of the rock? Is it folded? Is it faulted? So these becomes the characteristics of the rock. So when we study the structure of a rock, we study its composition, arrangement and characteristics of the rock. Right? So this is covered under the definition of relief and structure. Okay. So now there is another thing which is known as order of relief. Right? So there is first order relief, there is second order relief, there is a third order relief. Okay. So what are these orders of relief? So in first order relief. So in first order relief, what will you see? In first order relief, you will see the large features on the earth. Okay, the huge features on the earth, which are the continents and oceans. Okay, so these are huge features on the earth which you will see in the first order relief, like continents and oceans. So with every further order, we will keep breaking it down. So in second order relief, what do you see? You see probably huge mountain chains which spread over number of countries, like you see Himalayas, Andes, right? So these, where are the Andes? Andes are on the western coast of South America. Obviously, we will discuss a lot of mountains today, so I will show them all on the map today. Okay, so this happens in the second order relief. Now in the third order relief, what comes after mountains? So now you know that the Himalayas are divided into the greater Himalayas and the lesser Himalayas, right? Or the northeastern hills and mountains. So in the third order relief, suppose in the second order you've done Himalayas, so in the third order will come ranges, smaller ranges like Shivalik range. Okay. So this becomes the third order range, third order relief. Now next you come to fourth order relief. So a single hill like say Mount Kenya, Mount St. Helens, Mount Everest. So this a single feature that forms the fourth order relief. Now finally you have the fifth order relief. What is the fifth order relief? The feature of one area. So like suppose in the fourth order relief you studied a coast. Okay, some coast, maybe Florida coast. So then there must be bars present in that coast. Or you studied say a mountain, say Helen. So there is a cliff of the mountain. So that cliff split. So individual features which are present inside the fourth order, they come in the fifth order relief. So now you see that with every subsequent order, first order, second order, third order, we are breaking it further. So the first order example is continents and ocean, Pacific Ocean, North America continent, South America continent. Second order example is huge mountain ranges such as Himalayas or Andes. Third order relief forms the smaller mountain ranges such as Shivaliks. Fourth order relief will form single features such as a mountain or a hill like Mount Kenya, Mount St. Helens, Mount Everest. And the fifth order relief that will form of small individual features that may be present in the fourth order relief. Small individual features that may be present in the fourth order relief such as a cliff, a bar or a waterfall. Waterfall is also an example of this. So jog waterfalls, angel waterfalls, these are examples of waterfalls. Okay, so this is the order of the relief. Now, when we started the very study of geomorphology, I told you that geomorphology, it is driven by two types of processes, endomorphic and exomorphic. So there are processes in geomorphology which shape the different landforms. They are known as the geomorphic processes. So these are two such processes, endogenetic processes and exogenetic processes. Correct? So now when you consider the endogenetic processes, what happens is that these are the ones which derive their energy from within the earth. Okay, from within the earth, like how, because these are related to plate tectonics. Okay, so these are those processes which derive their energy from within the earth. Okay, and what are exogenetic processes? Exogenetic processes are the ones which happen out because of the agents outside on the surface of the earth. Okay, so what will be the energy behind these? So then every energy on the outer surface comes from where? Sun. And second thing which is less important is gravity. Okay, so they derive their energy from either sun or gravity. Okay, so now these endogenetic processes, these are the ones that are happening from inside the surface of the earth. So their energy comes from what? The heat which is generated inside the earth. That may be because of radioactivity, that may be because of melting. So because of these endogenetic movements happen. So now these endogenetic movements, these are of two types. So endogenetic movements, these are of two types. Number one, you have slow movements, and then you have fast movements. So in slow movements and fast movements, what is the difference? See, the difference lies in the time that it happens. Like in fast movements, you will have earthquakes, volcanoes, okay, earthquakes and volcanism. These are fast movements, fast endogenetic movements. So now the term fast, it refers to what? That the amount of time in which these happens. Like an earthquake, it happens within a matter of seconds. Volcanism, it happens between a matter of minutes. It does not refer to the time which is required for the preparation of such events. For the preparation of of an earthquake, God knows from how many time, for how much time the energy is being stored in the plates, or God knows for how much time in volcanism the magma is being filled up in the volcano before it actually erupts. So this term slow and fast is related to the actual time in which the things happen, and it is not related to the time of preparation of these events. Okay, so you have in endogenetic movements, you have fast movements and you have slow movements. Now the slow movements are further of two types. They are either epirogenic epirogenic or orogenic, or orogenetic, epirogenetic and orogenetic. So now what are epirogenetic movements? These are large scale continent building movements, right? And what are orogenic movements? These are mountain building movements, continent mountain building movements. Okay. So now in the aperogenic movements, what happens is that the whole process of continental building is confirmed. So in this, there is a process which is known as warping. So when a whole continent is uplifted, a huge area on a continental scale, okay, so when that is uplifted, it is known as upwarping. And when a huge area, which can be considered on a continental scale, it subsides or it depresses, that is known as downwarping. Okay. So upwarping and downwarping. So upwarping can also be known as emergence of an area, and downwarping can be known as subsidence of an area. And now what are orogenic movements? Orogenic movements are the mountain building movements. So before we move any further, let us revise geomorphic processes. They are of two types, endogenic processes and exogenetic processes. Endogenetic are further divided into slow movements and fast movements. Fast movements and slow movements, the term fast and slow is based on the process of the timing of manifestation of these events and not the timing of the preparation of these events. Okay, so the fast movements, you have earthquakes and volcanism. In the slow movements, you have what? Aperogenic and orogenic, or aperogenetic and orogenetic movements. So aperogenetic are large continental scale movements. When such large chunks are uplifted, it is known as upwarping. When such large chunks they subside, it is known as downwarping or subsidence. Orogenic movements are mountain building movements, and these result from what? That because of different forces such as folding, faulting, such orogenic movements are formed. So now we will come to orogeny, that is the process of mountain formation. So there are different types of mountains which are formed in different ways, right? So orogeny is not always only related to mountain formation is not always only related to what? The formation of continental the collision of continental plates. Okay, so it is not always related to that. There are other things. There are other different types of volcanisms and so other different type of mountains that are formed. So the first thing that we are going to study is type of mountains. So we will be studying four types of mountains: fold mountains, block mountains, volcanic mountains, and residual mountains. Okay. So the first type of mountains that we will study are known as fold mountains. So before that, what we have to study is that what folding actually is. So Earth's surface is subjected to various amount of stresses. Okay, there are a lot of stresses which are present on the surface of the Earth, right? So some of those stresses, they tend to compress the surface of the Earth. When something is being compressed, what will happen? A folding will occur, right? So this forces these two forces here, they are trying to compress the Earth. So hence the surface of the Earth, it buckles up. So this buckling of the Earth's surface is known as folding. So what is folding? It is the buckling of Earth's surface. So folding is buckling of Earth's surface. Okay. So now what can happen? There are various types of buckling of Earth's surfaces that can happen. So the first thing that we are going to study is the different types of folds that are formed. So either when the Earth buckles, it can buckle like this. Okay. So now in the terminology for folding, suppose this is an example of a typical fold. So this plane which tries to divide a fold into two parts which are as symmetrical as possible, that is known as the axial plane. Right? These two flanks of the fold, these are known as its limbs. Okay. So these are the limbs, the two flanks of the fold. Like if you see this fold here, so this one here and this one here, these are two limbs of the fold. Okay. So now based on this terminology of what is an axial plane, so this plane. So this plane here which will divide this paper into half, that will be known as the axial plane. Okay. So now we will study different types of fold. So first of all that we have to study is the two types, syncline and anticline. So what is a syncline and what is an anticline? So the buckling can either occur like this, the rocks can move like this, or compression can buckle it like this also in the form of a depression, right? So when the two limbs of the fold, they are moving in the opposite directions. So this limb is moving, this limb is dipping in this direction, whereas this limb is dipping in this direction, right? So this is known as an anticline. When two limbs dip in opposite direction, like this. So this limb is going this way, this limb is going this way, so it is known as an anticline. When the two limbs dip in the same direction, so this is also coming this way, this is also coming this way, that is known as a syncline. So when two limbs, this is dipping this side, this is dipping this side, so then a syncline is formed. Okay. So the first thing that is formed is an anticline and a syncline. So you see here, these limb is dipping here, this is dipping here, so this is a synclinal fold. Here you see this fold, this is dipping this side, this is dipping this side, so this is an anticlinal fold. So now what is the next one? The next thing is the folds can be either symmetrical or they can be asymmetrical, right? So when the one limb is steeper than the other limb, then they are known as symmetrical. So when they are both of the equal gradient, then it is a symmetrical fold. But if one limb is steeper and one is gentler, then it is known as asymmetrical. So one limb is steeper and other one is gentler. So this is an asymmetrical fold. Okay. So now these asymmetrical folds, they can be of various types. So when one limb is almost vertical, okay. So when one limb is almost vertical, it is known as, so one limb is like this, it's almost vertical, and the second limb is dipping. So in this case, it is known as an overturned fault. Now you see in this diagram, the force is coming from this direction. It's coming from this direction like this. Okay. So first syncline and anticline was formed. Then it further compressed it. So one limb started to become vertical and overturned fold was formed. So then what happens with time? Two limbs, they become parallel like this. So this is known as an isoclinal fold. Now what happens is that when one limb, because of so much of pressure that is coming, what is happening? That this limb, it is thrust over the previous limb. Over this is one limb and it is thrust over the other one, and the axial plane becomes almost horizontal. So here the axial plane is vertical. So axial plane becomes almost horizontal. Again you see the diagram. Like this. So initially it was what? Syncline, anticline. Then what happened? More pressure came, so an overturned fault was formed. Then what happened? More pressure came and this limb, the fault almost became horizontal. One limb becomes almost horizontal and the axial plane is almost horizontal. Okay, so this is known as an overthrust fault. This is known as overthrust fault. So what happens after the overthrust fault? What happens that if there is further pressure, so this limb is already like this limb is already, here it is already like this, already under pressure, it's horizontal. So what happens with further pressure, this limb, what will happen? It will break, because there is only till certain time that will move elastically and folds will form. After some pressure, some amount of pressure, what is going to happen? The limb is going to break off. There is going to be faulting. So what happens? That this part, it will break off. Okay, and it will move away, and this moving away, it can go up to tens of kilometers. Okay, and if suppose the rock form is saturated with water, then obviously slippage can be more, so that is, amount of water really affects it. And in such conditions, these overthrust faults which move away, these are known as nappies. So what are nappies? Nappies are like, basically this is a French word which means tablecloth. So like tablecloth, these are moved away for a huge distance. So these are known as nappies. Okay. So what were the three different types that we have started in fold? First is an anticline, in which two limbs dip in different directions. Syncline, two limbs dip in the same direction. Isoclinal fold, in which the limbs are almost parallel. Overturned fold, in which one limb is vertical. Overthrust fault, in which the axial plane becomes almost horizontal, and when the overthrust fault is further pressure is applied on the overthrust fault, one limb breaks and moves away. It can move up to tens of kilometers, and that is known as a napping. Okay. So the first, now since we have started folding, the first type of mountains that we have to study, they will be known as fold mountains. So these are the one which are formed because of compressional forces, like we have studied. Like I've just told you, why do folds happen? Because of the compressional forces. Then, so these are the different types of mountains that are formed. So first is the fold mountains, which are formed because of the compressional mountains. Like I told you, the process of mountain formation is known as orogeny. Okay, so orogeny is, it happened a lot of times on the earth. Okay, so there are different periods of orogeny. So the first one is Caledonian. So what did Caledonian orogeny, which mountains are formed there? The Scandinavian mountains. So the Scandinavian mountains, the Scottish mountains, and some part of North America. These were the mountains which were formed during the Caledonian orogeny. Then around 240 years back, million years back, what happened? Hercynian orogeny. So in Hercynian orogeny, what happened? Which were the mountain systems that were formed in the Hercynian orogeny? The Welsh Highlands. Where are the Welsh Highlands? The Welsh Highlands are in Britain. Then you have the Harz Mountains of Germany. Okay, so these happened in the Hercynian orogeny. So then next is the third one, and the most recent one is the Alpine orogeny. So during this period, this happened around some 30 million years ago, and during this period what happened? Alps were formed, Himalayas were formed, okay, and Rockies were formed. Okay, so now we come to the first type of mountains, which are known as the fold mountains. Fold mountains, they are formed by compressional forces, they are formed by folding, and the basic example of these is obviously Alps, Himalayas, and Rockies. So let's see them where they are on the world map. So you see here, Alps are here in Europe, Himalayas obviously everybody knows, and Rocky Mountains here. Okay, so these are fold mountains. They are related to compressional forces. Now the next type of mountains they are known as block mountains. The next type of mountains, they are known as block mountains. So when folding is happening, there is another like now we studied what we studied compression. So in there is also tension where the Earth's crust will be apart from each other. So in such case, fractures develop and there is movement along these fractures. Fractures develop because of tension and there is movement along these fractures. Okay, and there is movement along these fractures and along these fractures there is movement. So what happens when there is movement along fractures? So in geology, we study two types of terms, joints and faults. So what are joints? Joints are basically the fractures where there is no movement and faults is where there is movement. So here what happens that this is one block. Okay. In faulting what happens is I'm showing you the so along this is a fracture line. So these are the different rock types that are found in the lithology. So this is a fracture line. So what can happen? Either one part of the block can either move. This is a fracture line. So either one part can move down or one part can move up. So based on that, we have two types of faults. So the first type here is that this block which was initially like this, so one part of the block it has moved down, so this is known as a normal fault. So this has remained in its position whereas this has moved down. This is known as a normal fault. Okay, so now what is the other thing that can happen, that one block can move up, so in that again happens. So now this block has moved up with respect to this block. So this is known as reverse fault. Okay. So when this movement happens, there are striations made on the surface of the rock. So when this movement is happening around these rocks, so this is moving up or this is moving down. So there are striations made on this surface which are known as slick-in slides. So these striations, they actually help you to decide the direction in which the fault has moved. Okay, so these are the striations which help you decide in which direction the fault has moved. So now you imagine that there is an area, okay, with a lot of faults. Okay, so there is an area with a lot of faults. So there are blocks of earth which have moved up, blocks of earth which have moved down, again, blocks moved up, blocks moved down, blocks moved down. So what will happen? That a mountain-like structure is formed, mountain, valley, mountain, valley, mountain and valley, such structures are formed. So these uplifted regions by faulting, these are known as hosts and these are known as grabens. Okay. So these are hosts and these are grabens. So these hosts and grabens, they form a mountain structure which is known as block mountains. So while the fold mountains, how are they formed? Fold mountains were formed because of the compressional forces. So the block mountains, they are formed because of the tensional forces on the surface of the earth. Okay. So in this you have hosts and grabens. The uplifted parts are hosts. The parts which are left below are known as grabens. And what are the examples of these mountains? So their first example is the Vosges mountains which are present in France. So somewhere here there are Vosges mountains present in Europe. Then there is a Black Forest mountain which is present in southwestern Germany. Okay, so again in Europe there is another example that is known as Black Forest, and there is another which is known as Hunstruck mountains. These are also present in Germany. Okay, so there are Hunstruck mountains. So there are three examples of important. First is Hunstruck mountains of Germany. I'll write it here. First is Hunstruck mountains of Germany, Black Forest and Hunstruck mountains which are in Germany. Then you have the Vosges mountains which are in France. Okay, so Black Forests are in southwest Germany. Okay, so now the next type of mountains. First is what? First is the fold mountains. Second was block mountains. Now the third type is known as volcanic. So as these are the mountains which are formed because of volcanism. So there are typical single mountains which are present. So first example is the most common one, Mount Fuji in Japan. Then there is a Mount Mayen which is in Philippines. Okay, and then there is last one is Mount Merapi which is in Sumatra. Okay, so volcanic mountains, they are formed because of volcanism. So the most common ones, they are found on the circum-Pacific belt. What is the Pacific belt? It is known, it is a subduction zone of volcanism is happening. And in the circum-Pacific belt, what happens is there is a lot of volcanism, and this is also known as the ring of fire. Why? Because there is so much of volcanism. So here you have a lot of volcanic mountains. So the fourth and the last, this is the third type, and now the fourth and the last type is residual mountains. Suppose you have an area, uske upar, there are different agents of weathering and erosion that is happening. The different forces are trying to break it down. Okay, so when different forces, they try to break it down, what happens is that the broken down parts, they the soft rocks, they are broken down, whereas the resistant ones, they keep standing as mountains. So the typical example of this is Mount Monadnock. And where is Mount Monadnock? It is in USA. Okay, so the typical example of this is Mount Monadnock, which is present in USA. Okay. So coming to the important, revising it again, there are four types: fold mountains, example and Himalayas; fault mountains, example Hunstruck and Vosges and Black Forest; Third is volcanic mountains. Example: Mount St. Helens, Mount Fuji, Mount Meraki. Then finally, residual example: Mount Monadnock in USA. So now we will see the most important mountain ranges that are present on Earth. So the first one is Rocky Mountains. These are present in the on the western coast of America. These are fold mountains. Then the Appalachian Mountains. These were formed during the Hercynian again fold mountains. These are present on the western coasts of South America. So they continue from here: Peru, Chile, Bolivia, all this portion that they covered. Then Alps are another important part. They were part of the Alpine orogeny, which happened 30 million years ago, along with the Himalayas. Then we have been talking a lot about the Ural Mountains. So the Ural Mountains is from the western boundary of a country known as Kazakhstan. Okay, so these are the Scandinavian nations and the Scandinavian mountains which are present in the northern Europe, and this was also formed. This was formed during the Caledonian orogeny. Okay, in the divergent plate boundaries, we studied rift valleys. So Great East Rift Valley is found in Africa, and along the Rift Valley, there are various lakes that are formed. Okay. So if you see this line from the Red Sea to almost southern parts of Africa, a lot of lakes present along this particular line. So this type of highland feature that is found, it is known as plateau. So what is a plateau? A plateau is also known as a tableland. So what is it? It is a high elevated area, flat. Okay, so सबसे पहले there are two types of these plateaus. They can either be tectonic or volcanic. Sorry, there are three types. There are tectonic, volcanic, and dissected. Okay, so tectonic, volcanic, and dissected. So what happens here is the ones which are formed because of the tectonic forces of the earth, that they are known as tectonic mountains. And the example of this is the tectonic plateaus. The example of this is Harz Plateau in Germany. Harz Plateau in Germany. Okay, so these tectonic plateaus, what can happen is that at times they can be surrounded by mountain ranges. So the tectonic plateaus which are present between, which are sandwiched between two mountain ridges, they are known as intermont tectonic plateaus. So the one example which is a typical example is closer to us, that is the Tibetan plateau. So Tibetan plateaus between which two ranges? Between the Himalayas and the Kunlun. Okay, so it is between these two ranges, the Himalayas and the Kunlun range. Example of this is the Bolivian plateau. Bolivian plateau, as the name suggests, it is between the two ranges of Andes and it is in South America. So the Bolivian plateau is somewhere here. The Andes, they have a number of ranges. So somewhere between this, there is the Bolivian plateau, and here you have the plateau. These are the Himalayas, these are the Kulu, meet here, Pamir Not. So here you have the Tibetan plateau. Okay, so this is a tectonic plateau. Now what is volcanic plateau? As the name suggests, because of volcanism. So the example is there in India only, the Deccan plateau. So the northwestern part of the Deccan plateau is the volcanic plateau. There are Deccan traps, like I told you in one of the previous lectures. So these Deccan traps, these are accumulated to form the Deccan plateau. But the typical example of this is known as the Columbia Snake Plateau. So there was a continental basalt flooding in Columbia River. So they are known as Columbia River basalt. I will try to show it if there is in the map of USA, it is there. Okay, so here it is not there. So obviously it is not here. So in the Colombian state, it is present in the state of Colombia is there, and in state plateau, Columbia Snake Plateau is one of the typical examples of volcanic plateaus. Now next is the final term. This is the dissected plateau. So what are these dissected plateaus? So when there are huge highlands, what can happen? That they can be cut by rivers. Okay. So if in rivers they are cut, so for example, Scottish Highlands. So these huge plateaus, what can be done? These can be cut by various rivers. Okay, so the various rivers can cut these highlands, and or in arid areas, what can happen because of erosion? What happens? They form steep tabular masses. So these steep ridge tabular masses are known as mesa. So if these steep tabular masses, these are cut by great canyons, in that case it is known as buttes. Okay, so mesas and buttes. Okay, so now in plateaus, what have tectonic plateaus, volcanic plateaus, and dissected plateaus. So tectonic plateaus के अंदर volcanic plateaus examples are Columbia plateau, and finally the dissected plateaus, the one which are dissected with time, with age, they have been dissected by various agents of erosion such as rivers, right? So this is basically example is the Scottish Highlands. So in the arid areas, when they are eroded by wind, so what happens is they form steep tablelands which are known as mesas. But if these such tablelands they are cut by canyons, they are known as buttes. Okay. So this covers. So now we have done highlands, we have done plateaus, we have done mountains. So now we have to do what is lowland, that is plains. So high area cover कर लिया है, so we have to cover plains also, right? So what are plains? So plains are basically very monotonous features. What happens is that they are generally, there are